Okay, I'm going to do a sample on how to sketch the tangent curve. One thing that is important is to understand that this general form of the tangent curve is y equal a tan bx. And the period is always pi over b, because the period of the tangent curve, different from sine and cosine, the sine and cosine of a period of 2 pi, the tangent and cotangent have a period of pi. So if there's any coefficient in front of that pi, or in front of that x, that's the period, that's the number that affects the period. So in this case it's a 1, so the period is pi over 1. And the amplitude is A, just like in the sine and cosine functions. So let's make a chart to graph the tangent function, okay? So the tangent x, y equals tangent x. Let's make a chart for that. So x tan x. And we should pick some key values. Now, in terms of key values, you need to plot a few points. It's important to look at where are the asymptotes on the tangent curve, and you probably remember that one of them is pi over 2. And if you put your calculator in radian mode and do tangent pi over 2, you'll get an error because the tangent is undefined at that point. So that's an important point to graph. Now, some other values to think about on your graph. I have an easier time if I transfer this pi over 2 into some numbers. So what exactly is pi over 2 if you divide that out? So it's 3.14 over 2. Or use your pi button. So using the pi button, you'll get a decimal that's 3.14 and goes on and on and on. And then, so let's take some other values from that. Okay, so I made a chart using my calculator, and at 0, of course, the tangent is 0. At 0.5, it's 0.55, so at 0.5, which is somewhere a little bit past 0.4, it's 0.55, so I'm right there. At 1, I'm up at 1.6, so I'm up here. At 1.5, I'm all the way up to 14, which is off of my chart. And at 1.57, I'm at 1,256, way off of my chart. And again, the tangent curve continues down in this direction here. What happens at 3.14, or that's pi over 2, dot, 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 I didn't do that exactly. This is an asymptote, so the curve does not touch that. And then again here at negative pi over 2, we also have another asymptote, and this comes down here like that. Now the period, again, for the tangent curve is pi. So here at pi over 2 and at negative pi over 2, between this span I have a complete curve. What happens on this side, again, I'm down here, and then I cross over and go back up again. So this curve repeats and it repeats. Every pi, you'll get a new repeat of that curve. Now, so how does that differ from y equals 3 tan 2x? Well, in this one, the amplitude and the period is pi over 2 this time. So how does this curve differ from that one? Well, the complete tan curve in this picture ended in the span of pi. It went from negative pi over 2 to pi over 2. So this curve, the span is going to be shorter. It's going to be at the halfway point of this curve, and the halfway point here, I will have a complete curve. So if I take a picture here, this is the normal pi over 2. Now the curve is going to end at pi over 4, or half of that. And I'm going to have the complete tan curve. So that's where the asymptote's going to be instead of at pi over 2. Now this half of it here, and the other half of it down here. This is pi over 4. And my second half starts this way if you like to have one complete picture from 0 on. This is a nicer picture. So the new asymptote is here. So then I would have a second curve, you know, this way if I go further. The amplitude is 3. So that is harder to distinguish when you look at these curves, but it gets steep quicker. Again, you can plug in the values, and 3 tan 2x, there would be a 3 times all of those numbers. Again, I recommend trying to do a chart with some numbers. Use your calculator, put it in radian mode. You could put it in degree mode too. I like you to stick to radian so you get used to it. But good luck with these curves.